All right, so in 10.4, they talked about central angles and how knowing that central angle helps us determine two things um, about a circle. Okay, so a central angle is an angle that encompasses a part of a circle. Okay. Well, that central angle, extended from that central angle, is a radius. Okay, that radius uh, captures what they call an arc. Okay, actually, it defines two arcs, right? Say this is C, and this is A, and this is B. Okay, there's two arcs associated with this. There's a minor arc, and there's a major arc. And differentiate between the two. So this is our minor arc. Okay, there's angle ACB, angle ACB, and that corresponds with arc AB. That's the minor arc. Right, and then there's this bigger arc, right? Angle ACB, this bigger arc. And in order to identify that one, we'll take another point, and we'll make another point out here. We'll call that D, right? And we're going to call that angle or arc ADB. All right, so that's two ways to differentiate the two different arcs identified by this circle. All right, we have the minor arc. It's from here to here. We have the major arc from here to here. Okay, and if we know the length of or the degree of either one of these, we can find the length of both of those arcs, because there's 360 degrees in a circle, and we can find the ratio multiplier of that minor and major arc, right? So we're going to call this this central angle, we're going to call that psi, just because I feel like calling the central angle psi, right? Central angle is psi, okay? And all we have to do to find the minor one, I say this central angle here is psi, and we'll say it's 36 degrees, for instance. Okay. Well, we know there's 360 degrees in a circle, so part of that psi of that 36 degrees for arc AB is dedicated to AB. Well, 36 degrees. 36 degrees over 360 degrees just happens to be 1/10 of those dedicated of those 360 degrees, right? So arc AB is 1/10 of that perimeter of the circle. If I knew the radius of that circle, it would be 1/10 times 2 pi r, because the equation for a circle perimeter is, or circumference is 2 pi r. And that means the remaining portion of this major circle, this is for arc AB, that means for the remaining part of this arc is ADB, right, is going to be, well, 1/10 is a whole arc, right, it's the whole 10/10, right, so 10/10 minus 1/10 is 9/10, so the remaining 9/10 of that, or 90%, right, is going to be 9/10 of 2 pi r, right? And if another way to look at it is if I took like the 36 degrees away from the 360, I'd be left with 324 degrees, right? So 324 divided by 360 is 0.9, is 9/10. Or I could go 324 3/60ths, and lo and behold, it's 9/10, right? So that is how I find the arc length of the minor and major arc derived from this central angle. Okay, if I wanted to find the sector area, it'd be the same process, but instead of using the equation for circumference, we're going to use the equation for area, right? So the area of the sector of encompassed by AB, or by psi, right, is going to be 1/10 of pi r squared, right? That's going to be our colored in area. If I wanted to figure out like the area of the rest of this stuff, we'll call it area green. And I guess I'll call it omega. Why not? I don't know if you can even see that. Omega, kinda, sure. Right, omega, the area omega sector. These are called sectors, by the way. Sectors is 9/10 of pi r squared. Right? It's just copying the same thing, except we're using the area equation. All right, and you might get a little bit of trickier math in here, and maybe they're telling you that this is a diameter, a B is a diameter, which, or we'll call this, I already used B, we'll say this is F, right? This is a diameter, which means that this whole thing is 180 degrees, and you know, if this is 36 degrees, that means that this is 180 minus 36, and you have to figure out that too. So you just have to apply some brain power to it. Or maybe they have another intersecting angle here, right? And they're both, well, A, B, C, D, F, and this is E, right? And then they'll say that, you know, EF, they're both diameters, which means they're both straight lines, meaning that these are vertical angles, right? Meaning that these are the same arc length, and these are the same arc length. So they get tricky in there, and that these equal 180 degrees total, right? And so you have to use a little bit of your prior knowledge of geometry, dig deep in that tool bag, and maybe do some angle addition stuff or angle subtraction stuff to figure this stuff out. But you know all that, you can figure it all out with your prior knowledge. Okay? If you have any questions, let me know. Also, in addition, this is 10.5 as well. I don't want to make another one for 10.5. You might also be given variable statements with these as well. So if you're given a variable statement, you know that these are a certain value, and one of these is a variable statement. You know that maybe this is 10x plus 7, and you know that this is 36 degrees, and you know that 10x plus 7 plus 36 equals 180. You just make them equal to 180, and you can solve it that way. You know, just it's no different than what you've done in the past. It just adds a little bit more flavor to it. Okay? I hope this helps out.